Well, g'day Year 11s. Okay, so today we are learning how to graph hyperbolae. Hyperbolae is the plural of hyperbola. Okay, hyperbola. So as we've been doing, let's start with a formal definition. So a hyperbola is the locus of a point P that moves so that the difference between its distances from two fixed points that they're calling F1 and F2 is a constant. And that's a little bit hard to digest. So let's just have a look at this diagram right here, okay? All right, let's just say I plonk down two points on a page anywhere, all right? Okay, now in relation to those 2 points, what would a hyperbola be? Well, a hyperbola would be the graph that is traced out by this dot here, P, in such a way that the distance from F1 to P minus the distance from F2 to P is always a constant. Okay, so P could be anywhere. P could be right up the top here. If I draw a straight line to that point there, pretend that's straight, minus the distance of that line, which you also need to pretend is straight, then I'll get the exact same constant. All right. Now, if we start doing it over on this side, okay, and I do F1 to P minus F2 to P, obviously I'm going to get a negative answer. That's why we care about the absolute value. So the real rule is that the magnitude, the size, forget about plus or minus, the size of the difference between those two lines, okay, is always going to be a constant. And by doing a dot in every single place that satisfies this rule, okay, and there's infinitely many dots along our graph, we come up with a hyperbola. So it's pretty nifty. All right, so moving on to how to sketch these things. Well, once again, because we're so strapped for time with home learning, I'd like to normally go into a little bit more detail about where these formulas come from, but for the time being, you might just have to take my word for it that these few equations here are true, but you're more than welcome to go and do your own research on YouTube, okay? All right, so what is the general form of a hyperbola? Well, the first thing to say is that hyperbolae have asymptotes. They have two asymptotes each, okay? And those two asymptotes are diagonal and they intersect each other, all right? So if we have two asymptotes intersecting one another, okay, that's considered the center of the hyperbola, okay? And just to give you some idea of what I'm banging on about here, that top part and that bottom part there, for example, that is a hyperbola. These two diagonal lines here are asymptotes. I just haven't made them dotted. And this is the center of the graph, okay, which is the point where the two asymptotes intersect, which won't always be at the origin, by the way. All right, so here's the general form of the equation. X minus h all squared over a squared minus y minus k all squared over b squared equals 1. And it's going to look incredibly familiar to you because if that was a plus sign, then it would be exactly the same as the general formula for an ellipse, which is pretty amazing. You just change it to a minus sign, you get a completely different looking graph, okay? All right, so if we have x minus h and y minus k, then positive h slash positive k, so h comma k will be the center of your graph. In other words, it will be the location where your two asymptotes cross, all right? So how do we draw these asymptotes? Well, we have an equation, okay? Y minus k equals plus or minus b over a times x minus h. Looks complicated, right? Y minus k is just whatever is written here. x minus h is just whatever's written here, and the plus or minus b over a is just plus or minus the thing that's squared here over the thing that's squared here, okay? And those will give you two linear equations, like y equals mx plus c, and you know how to plot linear equations, okay? So you'll be able to graph those asymptotes easily. This over here is the general form so long as the center is 0, 0. So I didn't really need to include this because you could see that already. If h was 0 and k was 0, I would have x minus 0 and y minus 0, which is just x and y, okay? So if you have x squared on the top, nothing in brackets, and y squared on the top, nothing in brackets, and everything else checks out, you know you're dealing with a hyperbola that is going to be centered at the origin. All right, time for some examples. Oh, and one more thing. The general form of the equation of the asymptote, if it's centered at the origin, is this, which is simpler, okay? And that's simply because k and h are equal to 0. And if you put k and h in there equal to 0, you get this thing here, okay? All right, so let me scroll up a little. Let's do question 1a. Sketch graphs of the following hyperbolae, because we have two of them. I'm going to sort of talk about both of these at the same time, probably. Okay, first thing we want to do is find the equation of the asymptotes. So we can see that this graph is an x squared term minus a y squared term with nothing in brackets. So we know that our asymptotes are going to intersect at the origin, and we have a formula for that. It's y equals plus or minus b over a times x, okay, where b is the square root of the denominator of this second term here, and a is the square root of the denominator of the x term. In other words, 2 and 3, they're our b and our a, so y equals 2 over 3x and minus 2 over 3x, okay? And you have many different ways that you can select from to plot those two linear graphs, which are actually asymptotes. These two lines, diagonal lines, are asymptotes. Feel free to make them dotted lines. I probably should have. So I'm trying to think of the name of the method. The, what is it, the rise over run method or something? I mean, it's easy. You just need the rise to be 2 and the run to be 3. Or you could think of it like this, 2 over 3x plus 0. 0 is your y-intercept, so you start at your y-intercept. The rise is 2, so you go up by 2, and then the run is 3, so you go to the right by 3, and you get your second point. And when you've got 2 points, that means you've got a line, okay? But if you have another method for plotting your asymptotes, for plotting a y equals mx plus c graph, that's fine. But you have to plot both of them. All right. So now how do I decide where to put my focus points? Because an ellipse has to have, a hyperbola has to have 2 focus points. Well, what you do is, first of all, you look to see whether the first term is x squared and the second term is y squared. If it is, your graph will be oriented like this, okay? If it's a y squared term minus an x squared term, then your graph will be oriented this way, okay? Up and down as opposed to left and right. Simple as that. All right, so for this case, when our x squared term is our first term, all right, we look underneath the x. What is the number that we have squared? 3. So we go to the intersection of our two asymptotes, and 3 tells us how far we have to go to the right to get one focus point and how far we have to go to the left to get another focus point. 3 steps. And then you just have to say to yourself, well, I know generally what these things look like, and I'm going to have to intersect this point here, and I have to approach these asymptotes forever. So I'm going to get a line like this with an arrow here saying I'm approaching that line forever but never quite touching it, and the same down there, and you do the same over this side as well. Okay? And make sure you label the equations of the asymptotes, the overall equation of the hyperbola, the coordinates of the foci, and the coordinate of the origin. Okay, let's look at question B now. Okay, so the first thing we notice here is that we have a y squared minus an x squared term, 2 terms, okay? Which means we're going to be oriented this way with our graph, all right? Now, the equation for the asymptotes is the same, plus or minus b over a, where b is the thing that is squared in the denominator of the y squared term, and a is the thing that is squared in the denominator of the x squared term. So this time we get plus or minus b over a being plus or minus 3 over 2, plus or minus b over a x gives us y equals plus 3 over 2x and y equals minus 3 over 2x. So you plot those two linear graphs here and here, all right? And now we have to decide once again, now that we've done our two asymptotes, where are my two focal points going to be? And this time they're going to be along this direction. So in this case, we look at what is underneath the y term. So we look at our b value, and b is 3. So I go to the intersection of my asymptotes, I go up by 3 units, that's my first focal point. I go down by 3 units, that's my second focal point. And then I draw in my hyperbola, which is absolutely impossible to do with a mouse. Draw arrows on the end, label everything that I said to label last time, and Bob's your uncle. All right, I think it's time to move on to 2 examples where we don't have the origin as the point of intersection of the asymptotes. So here we go. Question 2. Sketch a graph of x minus 1 all squared over 4, which I've replaced with 2 squared, so a equals 2, minus y plus 2 all squared over 9, which I've replaced with 3 squared, so b equals 3, equals 1. Okay, so first thing we're going to do is find the equations of our asymptotes, and that is the equation that we're going to use, the general equation. So y minus k is simply whatever you have in brackets without the squared symbol here. So that's y plus 2. That equals plus or minus b over a, so 3 over 2, multiplied by x minus h, which is whatever is written here without the squared sign. All right, so if you expand that out, you get 2 solutions. Once you minus the 2 over the left-hand side, you get 3 on 2x minus 3.5, or you get minus 3 on 2x minus 1/2. So what you do at this point, and I've done it all the way down here, is you set yourself up a Cartesian plane and you draw the equations of your asymptotes. So how did I go about doing that? Because I'm not sure how much you've forgotten your linear algebra and how to plot linear graphs. So minus 3 on 2x minus 1/2. What you do is you go to minus 1/2, which is here, okay? Now minus 3 on 2, rise over run, but there's a minus sign, which means the rise part is actually a fall. So starting at negative 1/2 here is our y-intercept for this asymptote. We go down 3 units. 1, 2, 3, okay? And then I go 2 units to the right. 1, 2. All right. And I've got a dot. And I had a second dot here, my y-intercept, and then I connect them with a straight line and I have an asymptote. Then I follow the exact same process with the other equation and I'll get my two asymptotes. All right, now we're going to have to find some intercepts and their values, but you always do your asymptotes first because you don't want to do any unnecessary work. And you can see from the location of these asymptotes that it's impossible for our graph to intersect the y-axis, okay? Because our graph is going to go somewhere through here and somewhere through here. The x squared term is first, so this is the orientation, left and right, as opposed to top and bottom. And you can see it's impossible that our graph could intersect the y-axis. So that means let's not bother trying to find y-intercepts. And in fact, if you did try to find y-intercepts, you would end up with the square roots of negative numbers, okay, which you guys know all about. Because that's quite often what happens when you try to solve a quadratic that doesn't have a real solution. So that is what would happen. But we do have to worry about x-intercepts. See, we've got two x-intercepts there. So for the x-intercepts, we let y equal 0. Substitute that in to this bad boy. And we get this pile of junk here, okay? So I'm going to multiply this 4 over to the right-hand side. And then I get this nasty looking thing. But I have a constant of +1 and a constant of 52 ninths. So I minus 52 ninths over to the left-hand side. And I get a quadratic which is equal to 0, which means I can solve it using the quadratic formula, or whatever is your favorite method. Complete the square, whatever you like. So using the quadratic formula there, I get 1 plus 2 on 3 root 13 and 1 minus 2 on 3 root 13, okay? And if you put those two values into your calculator to convert them into a decimal, just so that you can locate them on the Cartesian plane, you will find that this here, so -1 and almost a half, is the value of that. And what's this? 1, 2, 3 and almost a half is the value of the other x-intercept. Okay, now the only thing remaining to do is to find the coordinates of the two focal points here, okay? Because our graph has to intersect the two focal points. So to do that, we trot back up here, all right? And because this is a graph that has our x squared term first, we look at the number that is squared underneath the x term, which is 2. It's 2 squared right there. Okay, so using that number 2, sorry, I'm having trouble with my stylus / clicky pad thing. Okay, the number under x squared was 2. So from the point of intersection of the two asymptotes, we go 2 to the left, that's that focus point, and we go 2 to the right, and that gives us that focus point. That's a leap of 1, 2. And we have our x-intercepts, and then we just have to draw graphs that intersect those. Or technically it's one graph, but it's sort of split into two sections that can never come into contact with each other. And then you've got to make sure you include all of the normal tidbits. Okay? And the origin there. Well, not the origin, the point of intersection of the asymptotes. All right, time for one more example, I think. I know this is a long video, but it's usually a long class. So here we go. Question 3. Sketch a graph of this thing. Y minus 2 all squared over 4, in other words over 2 squared, minus x plus 3 all squared over 1, in other words 1 squared, which equals 1. All right, so the first thing we notice is that our equation has the y squared term first, which means our orientation for our asymptote, so not for our asymptotes, for our graph will be up and down as opposed to left and right, okay? All right, so we write down the general equation for our asymptotes. We substitute in the appropriate values. So y minus k is y minus 2, and x minus h is x plus 3. Now b over a, our b is whatever is under the y squared term, and the square root of that, so 2, and the square root of whatever is under the x squared term is our a, and the square root of 1 squared is obviously 1. So plus or minus 2 over 1 is just plus or minus 2. All right, now if you expand that out, expand those brackets, and then plus this 2 over to the other side, you get these two equations here, which are the equations of our asymptotes. Nice simple linear equations, 2x plus 8 minus 2x minus 4. Now, I don't think I'll waste your time by going through how to plot those. I think you all probably remember that by now. So I've plotted those two asymptotes here and here, okay? And they have a center at, and we have to be a little bit careful here because the x term is second, but they have a center at minus 3, comma, positive 2. Okay, so let's confirm that we did that correctly. Minus 3 and then 2 up. Yep, that's the center. And now that I've found the point of intersection between the two asymptotes, I can go ahead and find my focus points, my foci. And whatever the first term is, no matter whether it's the y squared or the x squared term, in this case it's the y squared term, the number that is being squared, which is 2, tells us how far up or down from the point of intersection of the asymptotes we need to move to find the two focus points. All right, so here we are. So we take 2 leaps upwards and we get this focal point. And from here, we're at y equals positive 2, we take 2 leaps down and we get our second focal point, which just so happens to be on the x-axis, but it doesn't cross the x-axis, it just sort of kisses it, okay? So if we look at that carefully, we can see that although we do have officially one x-intercept, we've found it already, and it's this part of the graph, that's not going to intersect the x-axis anywhere else, nor is this graph. So all we have to do now is find the necessary y-intercepts. So we go ahead and we let x equal 0, substitute it into our equation, okay? Add this 9 over to the right-hand side and then multiply everything by 4, and we get this. Now we want to get the right-hand side to be 0, so we minus 40 over to the left-hand side, and we get an equation, a quadratic equation in y equal to 0 that can be solved using your favorite method. I just being lazy using the quadratic formula, and I get 2 solutions, which is what I want, 2 y-intercepts, 2 plus 2 root 10 and 2 minus 2 root 10. And once again, if you put 2 plus 2 root 10 into your calculator and then convert it into a decimal, it will give you this y-intercept, and 2 minus 2 root 10 gives you this y-intercept, awfully close to the asymptote. And then you just draw in your graphs and all the tidbits, okay? All right, pretty lengthy video, guys, but hopefully that was comprehensive enough for you to understand how this works. I wish you all the best. Please be in contact if you need help, and I'll talk to you soon.